Hello folks, this is Dr. Brown. I'm going to share with you some information about naming, and you were sent some of the naming rules that cover just about everything we need for this level class. And the information you were sent basically is shown here, and I'll kind of go over it with you, that compounds and elements have zero charge. Only ions have a charge. What that means is you've got to have the same number for compounds, you've got to have the same number of cation charge as you do anion charge to end up with a zero charge. So you've got to have the same number of pluses as you do minuses. As far as elements, all elements that are pure elements have a zero charge. And so in some common terms, if you have a container of anything, a jar of something, and it's going to have a zero charge because you would get shocked if it had a charge. When you're naming something, the cations are always on the left. That's the material with the positive charge. And the anions are always on the right. Those are the ions with a negative charge. Our first rule in naming is that lithium, sodium, potassium always have a +1, and almost always hydrogen has a +1. Also, magnesium, calcium, barium always have a +2, and fluorine, chlorine, bromine, iodine always have a -1. They end, when you pronounce the name, it ends in an ide, I-D-E. And the reason for those three rules is the fact that in our periodic table, we can see that the alkali metals here are, when we get into studying orbitals, we will see that there is a propensity for these elements to lose one electron, and there is a strong desire for all elements to either have a full outer shell of electrons or to have 8 electrons. So in the case of these, they will generally lose one electron and be in compounds in a +1 state, oxidation state. So these will be +1s. The alkaline earth metals, these are the alkali metals, alkaline earth metals will be +2 because they have a propensity to give up 2 electrons. When we lose 2 negative charges, the 2 electrons, they'll end up with a +2 charge. The halogens, fluorine, chlorine, bromine, iodine, will always have a -1 charge. Because of their desire to have 8 electrons, they'll pick up 1 electron. And you add in 1 negative charge, they'll always have a negative charge in the compounds they form. The halogens are generally very stable and do not form compounds. So again, the halogens are stable, they'll have a zero charge. That's the noble gases have a zero charge. The halogens will have a -1 charge. The alkaline earth metals will have a +2 charge, and the alkali metals will have a +1 charge. Okay, so that's the basis for our first 3 rules here, are these 3, that lithium, sodium, potassium always have +1, magnesium, calcium, barium always have a +2, and fluorine, chlorine, bromine, iodine always have a -1 charge, and an ide. We also need to know some common polyatomic ions, and the polyatomic ions you need to know are ammonium. Ammonium comes from ammonia. Oxide is O2 minus, and ammonium is +1. Sulfide is -2. Okay. The common acids that you need to know are sulfuric acid, H2SO4, phosphoric acid, which is H3PO4, and nitric acid, which is HNO3. This next statement, it says that the ic acids, see above, that's sulfuric, phosphoric, and nitric, yield the 8 anions. And these are the 8 anions below: sulfate, phosphate, and nitrate. So if you think of sulfuric acid and take away these 2 hydrogens, you'll end up with sulfate. If you know what phosphoric acid is, take away the 3 hydrogens, you'll end up with phosphate. The nitric acid, if you know what nitric acid is and take the 1 hydrogen away, you'll end up with nitrate. So depending on how many hydrogens you have, you'll end up with a +2 or -2 polyatomic ion called sulfate here, you'll lose, if you lose the 3 hydrogens here, you'll have phosphate, and 1 hydrogen here will be nitrate. So there's not quite as much memorization as you might think. You'll need to know, again, sulfuric, phosphoric, and nitric will give you sulfate, phosphate, and nitrate. Okay. Other common polyatomic ions you need to know are hydroxide, which is OH minus, carbonate, which is CO3, 2 minus. The strong acids are hydrochloric acid, which is HCl, hydrobromic acid, which is HBr. Other common compounds are water, which is H2O, ammonia, NH3, which we already talked about, methane, which is natural gas. That's what you may heat your homes with. That's what belches from cows, and that's what some of the gas wells in a little further south in Arkansas may be producing is methane. And table salt is another one. Because water is so common, it falls out of the sky in the form of rain. It exists in pools and ponds and rivers and oceans. Hydrates are very common. So a hydrate is a particle or salt that has water glommed onto it. And because water is everywhere, essentially everywhere, and prevalent in a lot of compounds, we need to define which hydrate we might have. So we have the second page, which has already been shared with you. If we have 2 water molecules glommed on, 2 would be di, so that would be a dihydrate. 3 would be, or tri would be 3, tetra 4, etc. But these words on the sheet that you were given indicate how many. They're associated with numbers. From mono to deca is 1 to 10. Okay, let's keep going through our rules here. That's waters of hydration. The oxidation state is just another name for the charge. So sodium, we talked about up here, has an oxidation state of +1. So don't let those words throw you. The transition metals can have many different charges. And because of the many different charges that the transition metals can have, we will designate what the charges are by using a Roman numeral. And again, the transition metals are in this range right here, these little lower metals. They have such complex orbitals, D's and F's, that backfill. You can have many different charges. So they will be designated with Roman numerals. There's an old convention also that's gone out of style to use Latin names like ferric and ferrous instead of Fe plus or Fe3 and Fe2. Okay. With that in mind, let's start naming some of these compounds and see if we can make sense out of some of these crazy rules we've got. Okay. Let's take a look at some of these. We've got NaCl. That would be sodium chloride. CaCl2 would be calcium chloride, and these end in IDE. Calcium chloride. Be sure you write that carefully. And this brings up a point when I indicated that all neutral compounds, that's calcium chloride, all compounds are neutral. This calcium is a +2 cation. Chlorine, each chlorine is a -1. To have these balanced, we have to have 2 chlorides to balance out the 1 calcium. That's 2 -1s to balance out the 1 + 2. In sodium sulfate, this is what this material is, sodium sulfate. Okay, sodium sulfate. We see that it takes 2 sodiums. Each sodium is a +1. Again, we know that because the sodium is right here in the periodic table. It's a +1. The sulfate is one of the polyatomic ions we need to memorize. That's a -2. So if this is a -2 or 2 minus, and each of these is a +1, then we'll need 2 of these. 2 +1s balance out the 1 - 2. That's why we have a 2 here. This sulfate always exists as SO4 2 minus. We don't ever break that up. Okay. Okay. Here's another naming convention. This is calcium hydroxide. CIUM, hydroxide. Okay, calcium hydroxide is a salt formed from Ca, which is calcium, and hydroxide. Now, the hydroxide is a polyatomic ion Hydroxide is OH minus, and that's minus 1, and this is a plus 2. So I need 2 of these. So the proper way to write this is to draw parentheses and a subscript 2. So that indicates that we have 2 of these. 2 of these balance that to make calcium hydroxide. Okay. Similarly, we may get into naming materials or drawing the structures of materials from the names. When we're asked to do that, we will, if we have iron 2 chloride, that Fe is iron and chloride is Cl. Okay, this 2 indicates that iron has a plus 2 charge. So if this has a plus 2 charge and these each have minus 1 charges, I need 2 of these. 2 of these balance that out. In chromium, chromium 3 nitrate, that's going to be Cr, and NO3 is one of the polyatomic ions we needed to know. Since this is a plus 3 and these are minus 1s, I put parentheses and put a 3 here. That's a plus 3 because we can read the Roman numeral 3. And these, each nitrate is a minus 1 because, again, that's one of the polyatomic ions that we need to know. So when you have more than one polyatomic ion, you put parentheses around it to indicate how many you have. If you have one of the transition metals, you will have a Roman numeral. We have a lot of other possibilities, things like barium, chloride, dihydrate would be written like BaCl2, a big fat dot, 2H2O. That would be barium chloride, big fat dot, 2H2O. That's barium chloride dihydrate. I'll put on a separate line. Dihydrate. Okay. So this number can be anything from generally just a few, 1, 2, or 3, but we would use di-tri-tetrapenta in writing out a name to describe what that is. I hope this helps. If you have questions, please give me a call or send me an email. Okay? Thank you.